Next up, we have SimWell US, which is also one of our sponsors as well. And they're going to be talking about optimization of a reverse logistics supply chain with an end-to-end digital twin solution. It's going to be David Larrivee, Maxime Leclerc, Sherwa Mahdi, and Joseph Moyer. It's going to be a little bit of a different presentation, and David Larrivee is going to go first, and then everyone else will follow.
Absolutely. Thank you, John.
Yep.
All right. So today we're here to present you, like John said, one of our project, the optimization of a reverse logistics supply chain with an end-to-end digital solution. One of our partner, RPM Eco, um, is offering an integrated system for managing contaminated plastic hydrocarbon container and a pesticide and fertilizer container. Basically, RPM is collecting those containers from different customers. They are recycling it. The third pillar at RPM Eco is the water treatment. RPM Eco is servicing customers all across Canada. They have more than 40 employees and more than 40 dedicated subcontractor. Now let's take a look at how RPM was working. So RPM had thousands of customers across Canada, and they had some kind of generation of product. So they had some weight every week, and the drivers would go to those customers and grab all those recyclable and bring them back to the collection center. One of the main issues is that all those clients were on a fixed interval, meaning they would be serviced every week, 2 week, month, and so on. Um, Another thing is that all those customers were on static routes. So all the drivers would do the same routes over and over. And this could be an issue if there's seasonality, which there is in the consumption. And to manage all of this, there were 2 employees just to assign and manage all the service call and all the operations around that. So RPM has three main stakeholders, and they regroup together and they had some wishes how to improve their operations. The first one is the drivers. The drivers are paid by the amount of weight they're bringing back to the collection center. So obviously they would like to have more kilogram per kilometer done, much less empty pickups. These are if the driver goes to a customer and there's just nothing to pick up. And finally, an easy to use mobile app. The second stakeholder is the coordinator. They want more visibility on what's going on the route because if there's a new service call, they would like to know on which route should they put that stop. Um, and they would like to also increase the driver's willingness to operate those routes. Finally, the manager obviously would like to increase the service level to their customer, ease the process for the coordinator and the driver, and increase the employee satisfaction. Having that in hand, RPM has worked on a vision. Basically, they want to get to their customer right before they call. That way, they will maximize the weight picked up and have the right service level for their customers. They would also like to have dynamic routing because static routing is not the perfect way to operate in these days. They want to be able to modify, keep track of all the routes, and reduce the effort linked to data entry. Basically, when a driver finishes his route, he goes to a scale, gets a scale ticket, bring back that paper to the collection center, and someone needs to enter this data into the database. So RPM went around in the market and tried to find someone that could help them to achieve this vision. And they found us, SimWell Consulting and Technology. We have a diverse team of simulation AI software engineers building world-class solutions. SimWell is one of the largest consulting firms specializing in AnyLogic modeling. We are based in Canada, USA, and we have a global team of engineers building models around the clock. So in this presentation, we will show you Oscal, which has a patent pending right now. We'll get to it later on. Our end-to-end solution, starting with Chirwa.
All right. Thank you, David. So at first, RPM arrived with a couple of challenges. They had a struggle handling the seasonality and the trend related to the weight picked up in each of their clients. They had a lot of service call, and that will overwhelm the coordinators, and the driver felt frustrated about going to clients without anything to pick up. Also, they want to be more proactive on how to handle new clients. To be able to answer those challenges, a predictive tool had been created to anticipate the weight available in each of the client facilities. It's based on historical data, and the main two methods that we are using are ARIMA, the method well known in the time series forecast in the literature, and Croston, a method inspired by the exponential smoothing. That method is used mostly for intermittent demand. Also, if you remember, we had challenges related to the how are we handling new clients, or if a client will have a drastic change in her consumption behavior. So for that, therefore, we combine that predictive tool with a supervised learning model to manage the client variability. We are then able to anticipate if the client consumption behavior necessitates us to change the method or the parameters inside the method that we are using. As you can see on those two graphs, since the implementation of those two tools, we are able to increase the service level and also reduce the margin of error between the weight predicted versus the weight pickup. I'll give Maxime to talk about the next challenge.
Great. So now that we can predict weight at the available customers, what does that mean exactly? That means any given customer will be able to predict at a certain point in time how much kgs he should have available. Once we have this information, what do we do with it, though? They used to have previously static routes, which was a problem with seasonality and stuff like that. So what we did here was build a simulation model to manage those priorities. So the simulation model uses agent-based modeling to simulate the different processes throughout the simulation. We use mostly state charts all along the way. From what we see on screen right now, there's different modes according to if we want to write in a database or not. You can change the date you want to simulate as well as the length of the simulation. Usually in the normal process, the RPM will use it for week by week because that's how we're going to get the best predictions for the customers. So the process of the simulation, first of all, it reads all the data from a cloud database. After that, which we didn't see on screen right now, we launched the Python scripts. So there's two different Python scripts that are launched. The first one will readjust the intervals for those new customers that we talked about. And the second one will, after that, do the predictions. Once we have the predictions, we'll have a list of the available clients for the simulation, which will be taken into account on screen right now. Throughout the simulation, we have a different route creation algorithms using a specific prioritization system, as well as the geographic information system. This allows us, to keep track of driving time. Driving time is really important in the trucking industry as it has many laws regarding it. When we create the routes, we'll tend to maximize the weight available in the trucks, and then we'll optimize the distance traveled between the customers of this route. We then have a route acceptance decision tree, and once the route is accepted or rejected, we return all this information to understand the process in the cloud database. As soon as the routes are done and the information is sent back, there are tools allowing the coordinators to work around with these routes. So on the left side, we see the route planner. This is a tool that allows them to add service calls, modify the routes, as well as remove certain clients if there's changes in their demand. And on the right side, we have the customer care center, which is used to modify these clients according to their needs. So now I will let Joseph pursue with the next challenge we faced in this project.
All right, so we've predicted our volumes, we've created our routes. Now what do we do with it? RPM originally had a system where the drivers would receive their routes digitally, and they would then return the results of these routes via a paper scale ticket. The paper part of the solution proved to be inefficient and unreliable. Inefficient due to the fact that it takes time and effort to return this piece of paper and then enter the data into the database asynchronously, and unreliable due to the fact that a piece of paper could be lost in transit. Additionally, the paper element made it difficult to implement this into our simulation model, so we decided to make a mobile application. The mobile application can handle the input and output of the simulation automatically. It does this by pulling the routes, pickups, information about the pickups, and so on for the driver on login. Once they log in, they can complete their route, enter information about the route, and this will then go back to the simulation via a cloud infrastructure and database. The database is based on MySQL, hosted on Azure Portal. This handles the operational work of RPM, and it acts as a communication medium between the app and simulation. The app also provides validation on the data of pickups, so it has a weight predicted and a threshold, and if the data is outside of this threshold, then the driver will be asked to validate and edit if necessary. So the mobile app closes the loop of the end-to-end solution, and I'm going to pass it back to David.
Thank you. So as we saw, we've created this end-to-end solution, and everything started with the historical data. We had quite a few CSV files, and we've used a pipeline in Azure to get this data into the database we've created. Having this information in hand, we were able to do some predictions and get what's the generation rate of each of those customers. Knowing what is the weight at each customer, we've created this simulation model, and we can create routes that are then sent to the mobile app. The drivers have their operational tool with this. They can enter all the data, and this data goes back to the database, and then we're doing this loop every day. The solution infrastructure is basically using Microsoft Azure, the SQL database. We have the Power BI and Power Apps connected to it, so we can modify different information, parameters. It acts like we can change the simulation input. We also have the prediction that are connected to it and the mobile app. Finally, on top of that, we have the simulation model in AnyLogic that is simply coordinating everything. And why did we use AnyLogic in this case? There was the GIS already integrated into AnyLogic that was perfect for us. The seamless facility in which we could connect to the Azure SQL, and the integration with Python was also really easy. So all in all, AnyLogic was the perfect maestro to orchestrate this solution. Now you may ask, what were the benefits of this solution? Well, all the stakeholders had some wishes at the beginning, and we've been able to provide and answer all those wishes. The coordinator now have a bird's eye view of everything that is going on. If a route is started, then they can see it. If they need to add some service calls, they know on which route they can put it. All the BI that has been integrated with that helps to take tactical and strategical decision. And overall, there's so much better operational data with higher security and governance. Since the beginning of the project, which was a little bit more than 2 years ago. We've increased by a total weight of 20% that has been collected from customers. The average weight per pickup has increased by 52%, and the number of empty pickup has decreased by 81%. If we take a closer look at this, there was different go live for different regions. The first go live was at early 2021, and the last go live was in June of this year. And as we can see, the number of pickup at zero has decreased tremendously. On the second chart, we can see the average per pickup has increased by around 50% since the last go live. So I hope you like this presentation. Should you have any question, we're here to help you. What's your favorite or remarkable project that you ever create in AnyLogic? Each of you. To me, that was this project, to be honest. Having an integration of all these technologies together, it was really cool, to be honest.
I think
I would say the same.
same. The same.
What is the biggest challenge you faced in this project? There was quite a few challenge with this project. Actually, just calibrating the whole system to be able to, one, the prediction needed to be good before we could start the go lives. We can't just say we're gonna predict and then go. We need to make sure that everything is validated, verified, and the prediction are good. Another challenge was about the route, making sure that we're creating good routes, not too long routes with enough weight. That's about it for the challenges. How did you specify seasonality into the model?
You want me to?
Yes, please.
So for that one, we were actually, the data wasn't, there were not any seasonality mostly on the data, because we're talking about and we're talking about like the consumption of, it's a recycling, as if you come back to the beginning, it's a recycling company, so they still have the same trending on terms of course there's a little bit of seasonality, but it's not as important as when you are in more in other type of market. But for that one, we didn't have a lot to handle the seasonality into that.
If I may add on top of that, Arima is better for seasonality than Croston, and with the supervised learning we have, we're reassessing each customer each week when we're visiting them. So if one type of customer has more seasonality than another, it will be placed dynamically on Arima.
Exactly.
How do you consider the mentioned behavioral attributes, drivers, willingness, and employee satisfaction? Basically, there was a lot of repeating operation that were done, like sending the same route each week to the drivers and having to grab a piece of paper, go on the computer, and then write the value. But then the driver lost the paper. So for sure, that increased the coordinator satisfaction and the driver's willingness to operate the route. Everybody loves a little bit of change. So not doing the same route on a Monday, on a Tuesday and Wednesday, and so on. I mean, they can see other region on other days of the weeks. And there's quite a lot of regions, so it's not just 5 regions per driver per week. So they're seeing their whole region throughout the month. Did you use Databricks for your Azure SQL data handling? Nope, we've used Pipeline. Can you talk about integration with Python and cloud services?
I think that's fair.
Well, for the Python, actually, the Python is simply reading from the database and writing the results back into the database. And then the simulation model will read this data to create the routes. And for the cloud services, what are the strengths and limitation? There's not much limitation. I would say maybe the services are a little bit more expensive than what we would expect. But the biggest strength is that we can access it from anywhere in the world. If something comes up, we can access it. And maybe like a service in a mobile app has some kind of issue, we can access and just repair it. I think it's much better having cloud than a physical computer in this case. All right.
I think that the question in the integration was related to in AnyLogic. So yes, we're using the terminal, like right now for the Python, we are calling it directly the script file into the folder. But right now we found that there were like a couple of new package that has been created as a pipeline and others that will work well with the Python script, and I don't think that there's a limitation on that also. Yeah.
There's quite a lot of questions. If you have other questions, go see us at the sponsor booth. We'll be there to answer other question if we don't have the time.
So one of the questions is, are you triggering a new model every time in the loop? So yes, every Friday or whichever date the coordinators want to launch the routes, they open, we've packaged it in a standalone way, and they just choose the dates and launch the simulation for the period they want.
We're generating routes for 1 week for all the drivers.
How would we improve the model? Any more integrations in the future? For sure, our client does more than just picking up the plastic. So that's under evaluation for the next phases of the solution, but maybe integrating it with the other services they do, because they pick up plastic, but then they treat the plastic. So this only covers the first part of their loop.
Was there any result in the model that made the stakeholders not trust the model? Yes. So I can think on top of my head of two things. The first one is the prediction. Sometime we would see that there was some predictions that were far away from reality, even though we did a lot of months on just validating that everything works together. So what we did is we tried to understand what's going on with these customers. We've looked into the data and looked at the historical data for those. And sometime we would see that there was a bad entry 3 years ago for these customers. Normally it's 40 kgs each time we visit it. And one time it was 6,000. So we knew that this was not right. So we've implemented a way to, if there's more than X amount of the average of this customer, just bring that number down. After we did that, the predictions were very, very close to reality. Another time. Yep, go ahead.
If I may add on this, another case related to sorry, the predictions. Let's say you have a customer that's active for the past 4 years, then you don't service it for 1 year and you reopen it. That gap year will affect the predictions. So sometimes we had cases like that, which we had to reassess because that was giving us bad results.
Good point. And another time is with the simulation, trying to understand why we're not visiting X region or X customer. There's no other way than just running some tests to understand which parameter in the database is affecting those results. All the regions are divided into different sectors, and those sectors, we need to visit them. So we had to find the right balance between the parameters to get to the results we're having right now. All right.
Cool.
Could it be applied in any other industry? I would say in any logistics industry, yes. How was the quality of the data and how did you handle it?
We already answered that.
Oh, yep, you're right. Thank you.
How long this end-to-end solution can be deployed? I think on this point we do have some we do have some triggers in the cloud services that allows us to scale up the packages we have. Regarding the simulation, we can scale up to more provinces as the deployment goes or as the need goes. It really depends on what the need is. I think it's more in the cloud services that this would be an issue, but that's regarding which cloud services you want to choose.
Yeah, this end-to-end solution is called Ascal with a patent pending. So there's a lot of work behind to be able to deploy it fast. And how much investment to implement, I would suggest that you send us an email so we can discuss around these detail to better understand what's the not the problem, but what do we need to change in the simulation to be able to get to your operational reality. How real time do you think this can get? Daily, hourly? The drivers are in real time with the mobile app. So if there's any change from the coordinator adding a new service call, the mobile app will refresh automatically. It's all in real time.
We for the routes we could go day to day. You won't want to go hour by hour because the driver will head into a direction and he kind of needs to know like his whole day to make sure he's okay in gas or whatever he needs to check depending on where he's going. But currently we do it for a week because we do have good predictions. It could be bring back to day, but they still like to know what they're doing for the remaining of the week. So that's why we currently do it week by week.
Still confused where the simulation is required in this problem. Sounds more like a dynamic optimization challenge. Capacitated vehicle routing problem. Maybe you could expand. So in this case, we've used AnyLogic because it is the maestro of everything. When we start, we needed a UI for the user to change some inputs. The simulation AnyLogic is sending the processes for the prediction, getting back the results. Then AnyLogic continues with the heuristic in the simulation model. We have some plans to expand with better optimization within AnyLogic. So yeah, the GIS integration was a big deal also for us, so we could get the distances. So that's why we've used AnyLogic and simulation. How many people basically works on the project? On our side, we were 4 or 5, I would say, and on RPM side, all the coordinator, IT managers, I would say 6 or 7.
Always depending on which phase we were developing at that time. Sometimes we were working with the drivers also to get
Yep.
their direct feedback.
All right. Don't see any other question. Thank you, everyone. See if you have other question, you have our email on screen. Feel free to contact us.
Awesome. Thank you very much, SimWell. Guys, once again, if there's any other questions, feel free to check out their sponsor booth that they mentioned.